Welcome to the next video. This is about modeling material flow inside Unity using the Open Commissioning package. So generally what we mean with material flow is the movement of different objects in the simulation that are not part of the machine or of the plant itself. So in many cases, those are parts that are being produced or modified or being worked on in the machine and are being transported in different ways through the process. We added a sample scene for the material flow modeling in the samples of the package, which I already opened. We see that there are different stations for different concepts, for different components, and we will start with the source and the sink component, which can create and delete payloads in the scene. But first, let's have a look at probably the most important component for modeling material flow, which is the payload component. So I'm going to add a prefab with a payload component inside the scene, so we can have a look at it. This component is the basic element for modeling the objects that should be moved and transported through the machine during the simulation. When this component is added to an empty game object, a box collider and a rigid body component are automatically added to it, so it can be influenced by physics and also be detected by other components like sensors, for example. There are a few properties of that component. One important one is the category, where you can set whether this payload represents a part, an assembly, or transport element. Then in the data, we have the type ID, which I will explain a little bit later. The unique ID is a number unique for every payload in the scene. So in this case, this is number 22, and a group ID, which has influence by which sensors the payload can be detected. So let's see how we dynamically can create payloads during the simulation. For that, we are using the source component. So let's select the source object to see how we can use that. So to create payloads using the source component is very simple. There's a create button in the component. When we click it, it creates a payload. At the moment now, it creates it and immediately it falls into the sink component. So let's move it a little bit to the side so we can see the payload that is created. So we see a new object was created. It fell down because of gravity, because it's a rigid body, and the new object created by the source is a payload. So it has the payload component attached to it. It has the unique ID 22. When we create another one using the source, this will get the unique ID 23. So it will count up the unique IDs of every payload created in the scene. But let's take a step back and see why exactly that payload was created, the part A. So another very important component for modeling material flow and open commissioning is the pool component. So we have here a game object called pool, which has the pool component attached to it. So this component is basically responsible for keeping track of all payloads in the scene. It provides a unique ID for new payloads that are created by sources or in other ways, and also has a list of all payloads that can be created in the scene by sources. So here in this example, in the sample scene, we see the list has 4 elements, part A, part B, part C, and an assembly. All of them are payloads, and they're also saved as prefabs in the samples. So whenever a source creates a new payload object, it instantiates a copy of that prefab into the scene. So again, a source can only create payloads that are referenced in this list in the pool component, and which one the source can create is defined and set in the type ID. So this number is referencing the index of the payload list in the pool component. So at the moment, the type ID is 0. When we look in the pool component, the first element of the list is part A, which is exactly what was created, a copy of part A. When we change the type ID to 1 and click create, we will see another payload was created, but it was part B. Which is the second element of the list here. When we change it to 2 and create the payload, it created a copy of part C, which of course in the pool component is the third component. So this is where we define which payload is created by this specific source. So now I want to quickly show how to create a new payload prefab that we can instantiate in the sample scene. So first we have to exit the play mode and then create a new prefab. So let's create a new prefab. Let's call it part new. Okay, let's open it. Let's create a simple 3D object inside that. Let's make it a little smaller, 0.1, and add the payload component to it. We see the rigid body and box collider have been added. Let's adjust the collider size to the geometry. And this is basically it. So just one simple geometry and the payload component is enough. We can save that. Go back. Let's add that prefab to the payload list in the pool. So we click plus and add this prefab as a new element. So now we can go back into play mode. Go to the source, move it away from the sink, set the type ID to 4, which is the index of the fifth element, and now create, and we see a copy of our newly created part was instantiated. Let's also have a quick look at the sync component. We already saw it deleting payloads that were entering its box collider. We see here it has a delete function, which deletes the payloads inside its collider, and also a setting auto mode, which means that they're deleted automatically as soon as they're entering the box collider. So when we uncheck that, move the sync to the payloads, we see now that there is a collision. So it's detecting the payloads. We can click delete, and it's deleting every payload inside its collider. So now we deleted every payload that we created with the source before. So now that we know how to create and delete payloads in the simulation, let's continue and have a look how we can handle them in the simulation. So one common function is to pick payloads up and place them somewhere else again. And for that, in open commissioning, there's a component called the gripper. So let's have a look at that now. Let's quickly hide the other examples to get a better view for that. Okay. So what we have here is an object representing an assembly which contains 9 parts that are all payloads. So they can be picked up by the gripper. The gripper is here, represented by this cube, and it has the gripper component attached to it. So the basic function of the gripper component is quite simple. It has a box collider, and if it detects payloads during the simulation inside that area, they can be picked up using the pick function, and then they get attached to the gripper, can be moved around with it until they are placed again using the place function. So let's see that in action. Let's start the simulation by entering play mode. So let's see that in action. Let's start the simulation by entering play mode and move the gripper down to the payloads. So we see here there's a collision detected, meaning that there are payloads inside the detection area of the gripper. So when we press pick and move the gripper up, we see that they are now attached to the gripper component. We also see that here in the hierarchy, all the parts with the payloads are children of the gripper component. So now they can be moved around when we move the gripper, and when we press place, they will detach and be removed as child objects of the gripper. So they are placed. Now we move the gripper up and we see they are not attached anymore. In the gripper component, we also can set which payload type the gripper can pick up. So we can choose between part, assembly, and transport, and then only payloads of that category can be picked up. If we need even more granular control which payloads can be picked up, we also can set a group ID in the gripper. So only payloads with that group ID can be picked up. So for example, let's set this to 1 and also set the group ID of one payload to 1. And when we start the simulation now, move the gripper down and pick, we see only that part got picked up because it has the group ID that is defined in the gripper here. Another thing to note is where the payload's game objects are being moved in the project tree during picking and placing. So now at the beginning, we see we have a payload assembly, which is the black plate here, which has the part payload game objects as its children. So when we grip the parts with the gripper, we see that they became children of the gripper component. And when we place them, basically like in the air, they fall down and become children of the pool object. So that is the default behavior if the gripper doesn't detect any assembly payload or transport payload in its detection zone. When it's placing the gripped parts, then they will just be released and be children of the pool object. When we grip them again and move the gripper a little bit more down so it can detect the collision box of the assembly payload and place it, we see that the gripped parts now are again children of that object. So it automatically detects whether the parts should be placed to an existing assembly. And if it detects that, it moves them as children into that assembly object. One other thing to mention for the gripper is that you don't have to click, pick, and place manually all the time. Those are public functions of that component, so they can be called from any other code or be connected to other components. For example, if you have a pneumatic gripper, you could call the pick function when the cylinders are extended and call the place function when the cylinders are retracted. So you have more flexibility and you don't have to click that manually. You can automate that and change it depending on your use case. Okay, so now move on to the next way how we can move payloads through the simulation, which are transport surfaces. Most of the times, those components are used to model conveyor systems that can transport payloads. So in this example, we have 8 transport surfaces. 4 of them are linear and 4 of them are curved, so they can transport payloads around a circle. So let's have a look at the linear transport component. So generally how the transport surfaces work is that they have a box collider and a rigid body, and every payload that sits on that body gets moved along the positive z-axis with a specific speed. That speed is provided by an actor, for example, by a drive, which is referenced in the actor property of the component here. The dimensions of the transport surface can be set here, which automatically updates the size of the box collider accordingly. The isDynamic option is relevant if the transport surface itself is moved, and the isGuiding option is relevant if you need really precise guided movement along the transport surface. But for now, this is enough. Let's start the simulation and see this in action. So we have, as I mentioned, this loop here where the payloads will be transported on. It consists of 4 linear surfaces and 4 curved ones. The only difference for the curved ones is that they move the payload around a specified curve. The principle is the same. There's a box collider and a rigid body, and when a payload is on them, they get transported along the curve. So let's create some payloads that can be transported on. We included a source component where we can spawn the payload objects. So as we can see, they are landing on the first surface and are being transported around the loop with the same speed. This is because all the transport surfaces have the same drive referenced as their actor. So they're all getting the same target value. So the payloads are transported with the same speed. When we look into the actor, we see that the target is specified here. We can also stop it. Then all the payloads are stopped on the surfaces as well. We can move backwards. And then we see the payloads are moved in the opposite direction. So this brings us to the end of the video. We hope that this was helpful for you in getting started modeling material flow in open commissioning.